Okay, so let's move on to part 3 of our video. So we're going to do some AP style problems involving taking derivatives and tangent lines. So the directions for the first one ask us to sketch the graph of a continuous function f with f of 0 being equal to 0 and f prime of x defined as -2 when x is less than 1 and 3 when x is greater than 1. Now I'm going to tell you that all 4 of these examples that we're going to look at here, like these are all test level questions, and there's a good chance you're going to see stuff similar to this on your test. And I want you guys to try to take what you've learned and work through these on your own. Okay? If you get stuck, that's fine. Like you haven't seen things quite like this. So, you'll get like better equipped to do these problems like the more you practice with it. But this is kind of to like develop your critical thinking and problem solving skills and see if you can apply what you've learned to different types of problems. Okay, so for this one here, we want to sketch the graph. Now, the key to doing this problem, there's 2 statements that are really important. Okay, number 1 is that f of 0 is equal to 0. So that tells me my starting point is going to occur at the origin. Okay, and secondly, that the function is continuous. Okay, and we're going to talk about what that means momentarily. Okay, now the third piece of information that's useful is we have f prime defined this way. Now, if we think about what f prime tells us, f prime tells us the slope of our graph. So we know the slope of our graph. When x is less than 1, our graph has to have a slope of -2. Okay, so when our x values are less than 1, our slope has to be -2. So that means if I want to go from the point at 0, 0 to our point on the graph at x is equal to 1, I have to draw my segment with a slope of -2, which means I'm going to go down 2 units and run 1 unit, okay, to get to that point. Now, if the slope of our graph to the left of 1 is always -2, then I'm going to extend this line out to the left. And again, as I go from left to right on that line, that slope is negative. I'm going down. Okay, then when x is bigger than 1, f prime is equal to 3. Okay, so again, f prime tells me the slope of my graph. So if the x values are bigger than 1, then my graph has to have a slope of 3. So if I want to get to the next point on my graph, I'm going to have a slope of 3. So I'm going to go up 3 units, 1, 2, 3, and to the right one. That's going to put my point right there. And all of the x values that are larger than 1 have to have a slope of 3. So I'm just going to extend my line in this direction here. So the question then becomes, like, why does our derivative not exist at x is equal to 1? Like, why is our function not differentiable at 1? And when we look at our graph at 1, our graph has a corner at that point, and we know the derivative is not going to exist at a corner. Okay, let's move on to number 2. So number 2 says to find the point or points on the curve f of x equal to 6 plus x minus x squared, where the tangent line is horizontal. Okay, I want you guys to give that one a try. Okay, now this is what I love about calculus. There are instances where you can do problems like this And you don't even need to use calculus. Because if you take like what you know about quadratic functions, you know the tangent line for a quadratic function is going to occur at the vertex. Okay, so if you calculated the coordinates of the vertex, that's going to tell you where the tangent line is horizontal. So you can do this problem without using calculus at all. But we're in a calculus class, so let's go ahead and use calculus for this problem. So if we want to find where the tangent line is horizontal, we want to find where the derivative of our function, which is f prime of x, we want to calculate where that derivative is 0. Because again, the derivative measures the slope of the tangent line. If the tangent line is horizontal, we want to calculate where the derivative, which is the slope of the tangent line, is equal to 0. Okay, so let's go ahead and calculate f prime of x. So the slope of the tangent line, which is f prime of x, is going to be using the limit definition. It's the limit as h goes to 0 of f of x plus h. So that's going to be 6 plus x plus h minus x plus h squared minus f of x. So I have to subtract that entire quantity. Okay, so 6 plus x minus x squared all over h. Okay, so this becomes the limit as h goes to 0 of 6 plus x plus h. You guys don't mind, I'm going to combine two steps in one, so I'm going to FOIL this out, and then I'm going to distribute the negative across all of the terms. Okay, so when I do that, I get minus x squared minus 2xh minus h squared. Then we have minus 6 minus x plus x squared all over h. Let's figure out what we can get rid of. Okay, so we have a positive 6 and a negative 6 that we can cancel. We have a positive x and a negative x that we can cancel. And then we have a negative x squared and a positive x squared that we can cancel. And again, if we did the difference quotient right, we should be able to factor in h out of the numerator, which we are able to do here. So when I factor in h out, that leaves me with 1 minus 2x minus h all over h. So once we cancel those factors of h, now we can directly substitute this limit in the place of h. Okay, which makes f prime of x equal 1 minus 2x. So all we want to do here is we want to figure out where 1 minus 2x is equal to 0. And that happens when 2x is equal to 1 and x is equal to 1/2. Okay, so it says to find the point. So that's going to be the x coordinate of our point. And then we have to plug this value here into our function to find the y coordinate at that x value. Okay, so that's going to be 6 plus 1/2 minus 1/2 squared, which is 1/4. And then I want to get a common denominator of 4. So 6 is 24 over 4 plus 1/2, which is 2 over 4 minus 1 over 4. So the y coordinate of our point is 25 over 4. Okay, so again, you guys can work that problem out with calculus or without calculus. Again, we want to practice with calculus because we're less familiar with that. Okay, let's do this one next. So directions here say to consider the curve y is equal to 2x minus x cubed, and the chord AB joining the points A, which has coordinates -2, 4, and B, which has coordinates 2, -4. And then we're asked to find the points on the curve where the tangent line is parallel to chord AB. Okay, so there are two things that we need to find here. We need to find the derivative of our function, which is going to give us the slope of the tangent line. So let's go ahead and do that first. Okay, so we want to find the slope of the tangent line, which in this case is y prime, which using the limit definition is the limit as h goes to 0 of f of x plus h minus f of x. Sorry, f of x plus h, which is this. Then we're going to subtract the function f of x, which is 2x minus x cubed all over h. Okay, so if you guys don't mind, again, I'm going to combine a couple of steps here in one. So I'm going to distribute 2 across the first two terms. So that's 2x plus 2h. And then I'm going to use the binomial theorem to expand this out. In addition to that, I'm going to distribute -1 across all of those terms. Okay, so that's going to be minus x cubed minus 3x squared h minus 3xh squared minus h cubed. And then I'm going to distribute -1 across the last two terms. So that's minus 2x plus x cubed all over h. Okay, so let's look at what terms we can get rid of. So we have a positive 2x and a negative 2x that we can get rid of, and a negative x cubed and a positive x cubed that we can get rid of. And then again, if we did the difference quotient correct, we should be able to factor in h out of the numerator, which we can. So that gives me h times 2 minus 3x squared minus 3xh minus h squared all over h. And then we can eliminate those factors of h. And again, that was what made the numerator and denominator 0. So now I can use direct substitution. So when I plug 0 in the place of h, this goes to 0 and that goes to 0, which makes y prime, which is the slope of the tangent line, equal to 2 minus 3x squared. Okay. Now, if we want the tangent line to be parallel to chord AB, so if I want the tangent line to be parallel to the line that passes through those 2 points, I'm going to calculate the slope of the line that passes through those 2 points. Okay, so the slope of the chord will be y2, which is -4, minus y1, which is 4, all over x2, which is 2, minus x1, which is -2. Okay, so that becomes -8 all over 4, which is -2. So if we want our tangent line to be parallel to that chord, then that means that the slope of the tangent line and the slope of the chord have to be the same. Okay, so that means we're going to set 2 minus 3x squared equal to the slope of the chord, which is -2. And then we're just going to solve this equation for x. So I subtract 2 on both sides. We get -3x squared equal to -4. I divide both sides by -3, so we get x squared equal to 4/3. And then we take the square root of both sides. So that's going to give me the absolute value of x equal to 2 over rad 3. And then I can drop the absolute value bars, putting a plus or minus in front of the radical on the right-hand side. Now, the thing that you guys will appreciate here in calculus is you guys don't need to rationalize denominators in calculus. Okay, so again, like if you were to rationalize that, I know that that would be 2 rad 3 over 3. You don't have to do that in this class. Okay, so that gives me the x coordinates of both of my points. The first one is positive 2 over rad 3, and the second one is -2 over rad 3. And then we have to plug that into this function here to get the y coordinates of both of those points. Okay, so when x is positive 2 over rad 3, we get 2 times 2 over rad 3 minus 2 over rad 3 cubed, which is 4 over rad 3 minus 2 over rad 3 cubed is 8 over 3 rad 3. And then if I got a common denominator of 3 rad 3, this becomes 12 minus 8 over 3 rad 3, which makes the y coordinate of that point 4 over 3 rad 3. Okay, so those are the coordinates of my first point. And then we do the same thing with the second point, so that I'm going to do the calculation for that down below. Okay, so that's going to be 2 times negative 2 over rad 3 minus negative 2 over rad 3 cubed, which is going to become negative 4 over rad 3. The negative 2 over rad 3 cubed becomes negative 8 over 3 rad 3, but when I subtract that, that becomes plus 8 over 3 rad 3. And then my common denominator again is 3 rad 3. So this would become negative 12 plus 8, which is negative 4 over 3 rad 3. Okay, so those are your 2 points where the tangent line is parallel to that chord. Again, very good test level question. Again, make sure you know how to do these for your quiz and for your test when it rolls around as well. Okay, toughest question of the day is the next one. This one here is a real challenge. You really have to think to work through this one. All right, so directions here ask us to find the equations of all lines tangent to y is equal to 9 minus x squared that pass through the point 1 comma 12. Now, this question is different, and this question requires more thought than the previous questions we've looked at. And we're going to take a look at why that's the case. Okay, so I want to draw a picture of what's being described here because we're going to see like the issue that we run into with this problem. Okay, so the graph of 9 minus x squared like graphically, it's the graph of x squared reflected about the x-axis and then shifted up 9 units. Okay, so graphically you're going to get some function that looks something like this. And then we want the the equation of the tangent line that passes through the point 1 comma 12, which is this point up here. Now the problem that we have, and this is the first example that we've looked at of this type, is that point does not lie on the graph of our function. And you can tell that, like you don't have to graph the function to tell that. Like if you were to plug the point 1 comma 12 into your equation, like that's not going to give you a true statement, okay, which means that that point does not lie on the graph of our function. So we've got a problem here. We know that to find the equation of the tangent line, like we need to determine the slope of the tangent line, which we can figure out the slope of the tangent line by taking the derivative of our function. But we also need a point of tangency. And that's the issue that we don't have. Like we don't have a point of tangency in this question. Now, when you look at this graphically, I think that there are like two tangent lines that make sense here. Your first tangent line is going to come from somewhere like over in here. And your second tangent line is going to come from like somewhere over in here. Okay, so we have to figure out where the points of tangency occur, and we need to be creative in order to do that. Okay, so let's talk about how we're going to figure that out. All right, so first thing we want to do is I want to take the derivative of my function to calculate the slope of the tangent line. Okay, so I want to calculate the slope of the tangent line, okay, which is going to be y prime, which using the limit definition, that is going to be the limit as h goes to 0 of f of x plus h, which is going to be 9 minus the quantity x plus h squared, minus f of x, which is the quantity 9 minus x squared, all over h. Okay, so again, I'm going to combine a couple of steps in one. I'm going to FOIL out x plus h squared, and then I'm going to distribute 1 across all of those terms. So this is going to become the limit as h goes to 0 of 9 minus x squared minus 2xh minus h squared. I'm going to distribute -1 across the next two terms. So that's minus 9 plus x squared all over h. And then let's simplify the numerator. So we have a 9 and a -9. We can cancel those. Negative x squared and a positive x squared. We can cancel those. And then I can factor an h out of the numerator, which leaves me with -2x minus h all over h. So once I cancel those h's, then I can use direct substitution and plug 0 in the place of h, which means that the slope of the tangent line, which is y prime, is equal to -2x. So that's good. That gives me the slope of the tangent line. The problem is I don't know where to evaluate y prime at, because I don't know where the point of tangency occurs. Okay, so this is where we need to think. If I want to calculate where the point of tangency occurs, we know that our tangent line has to touch our curve at some point. Okay, so the point where our tangent line touches the curve is going to be some point x comma y, which in this particular case, y is 9 minus x squared. Okay, so our ordered pairs on the graph of our curve are going to be of the form x comma 9 minus x squared, and our tangent line also has to pass through the point 1 comma 12. So if our tangent line passes through both of those points, I can find the slope of the line that passes through these 2 points here. Okay, and I can calculate the slope of the line that passes through those 2 points using the slope formula for those 2 points. Okay, so the slope of the line that passes through those 2 points is going to be my y sub 2, so I'm going to call that 9 minus x squared, minus my y sub 1, which is 12. And I'm going to divide that by the run, which is x sub 2, which is x, minus x sub 1, which is 1. Okay, so what we have here, that is just the slope of the line passing through those 2 highlighted points. Now, again, we said our tangent line has to touch our curve at some point and also has to pass through the point 112. So the formula that I just starred here, that is the slope of the tangent line. What else is the slope of the tangent line? Well, we just found -2x to be the slope of the tangent line as well. So I can set the slope that we just calculated equal to the slope of the tangent line that we found by taking the derivative. And when I solve this equation here for x, what that's going to do is that's going to give me the point or points of tangency. Okay, so if I want to solve this equation for x, I can multiply both sides of the equation by x minus 1. So I'm going to combine two steps in one. I'm going to simplify this numerator. So I have 9 minus 12, which is going to make that numerator become negative x squared minus 3. And then I'm going to multiply both sides by x minus 1. So that's negative 2x times x minus 1. So this is negative x squared minus 3 equal to negative 2x squared plus 2x. And then if I want to solve this equation here for x, I'm going to move all the terms to one side. So I'm going to move all the terms to the left-hand side. So when I add 2x squared to both sides and subtract 2x on both sides, that gives me x squared minus 2x minus 3 is equal to 0. And that equation there is factorable. That factors to x minus 3 times x plus 1. And that's going to be x is equal to 3 and x is equal to negative 1. Okay, so those are going to be the 2 points of tangency. And if we look at our graph, like, those potentially make sense. Like, if we have x is equal to negative 1, like the point of tangency here looks like it will pass through that point, and the point of tangency at 3 looks like it passes through that point as well. Okay, so we're almost done. All we have to do now, these are our 2 points. X is equal to negative 1 and x is equal to 3. If we want to find the equations of the tangent lines at those 2 points, the 2 things we need to find are the slope of the tangent line at those 2 points and also the y-coordinates of our points of tangency at those 2 points. Okay, so if I want to calculate the slope of the tangent line, the best way for me to do that is to evaluate y prime at negative 1. So y prime of negative 1 will be negative 2 times negative 1, which is going to make the slope of the tangent line 2. And then our point of tangency, when our x-coordinate is negative 1, I can plug that into my original function here, and that's going to make the y-coordinate 9 minus negative 1 squared, which is 9 minus 1, which makes the y-coordinate 8. And once we have the slope and point, we can plug that into our point-slope formula. So that's going to be y minus the y-coordinate 8 equal to the slope 2 times x minus the x-coordinate negative 1, and x minus negative 1 is the same thing as x plus 1. All right, so that's going to be our first tangent line equation. And then for the second one, at x is equal to 3, we need to calculate the slope of our graph at 3. So we're going to take our derivative y prime and evaluate it at 3. So when I plug 3 into my derivative there, the slope is going to be negative 2 times 3, which is negative 6. So that's the slope of the tangent line. And then we also need our point of tangency. So the x-coordinate of the point of tangency is 3. And then we're going to plug that value into the original function to get the y-coordinate. So that's 9 minus 3 squared, which is 9 minus 9, which makes the y-coordinate 0. And then once we have that, our equation of the tangent line is going to be y minus the y-coordinate 0 equal to the slope negative 6 times x minus the x-coordinate 3. All right, and our marathon lesson is finally done. So again, that's going to be one of the longer lessons of the year. And honestly, it's really like I'm combining 2 sections in one, which is going to make the next lesson in 4.2 shorter because I've talked about a lot of the stuff that you guys are going to see in that lesson as well. Okay, so that's it. Hope you guys have a great weekend. We'll see you on Monday. Take care.